In this problem, again, we're given the task of doing something somewhat complex. We have taken a chemical compound, completely broken it down, found its components, found their proportions. In this case, a compound that is made up of only two elements, carbon and nitrogen. 17.65% of it by mass is carbon, and 82.35% by mass is nitrogen. I'm being requested to find its empirical formula. Again, chemical formulas require that we get the molar ratio or atomic ratio of each of the elements. So I could choose any amount of this material, and using the law of constant proportions, I could do that. And I'm going to make it easy though and choose 100 grams, since percentages are based on 100. So out of that 100 grams, 17.65 is carbon and 82.35 grams are nitrogen. I need to change these to number of moles. So again, using a wheel diagram, we want to divide by the molar mass. I've got almost 1.5 moles of carbon. I'll do the same thing now for nitrogen. I've got 82.35 grams. Divide by its molar mass, and I find I've got, almost 6 moles of nitrogen. I've got numbers that are could give me the ratio, I guess I should say, but they're not going to be very nice. So I like to generate whole numbers. I look at these two values. I'm going to divide by the smaller of the two, 1.470. When I do that, I am able to generate whole numbers, 1 for carbon and 4 for nitrogen. So my empirical formula for this compound is CN4. That merely told me what is present and what is the basic ratio, 4:1 or 1:4. Now, I'd like to go further than that, and I'd actually like to find the molecular formula, the true formula for this compound. But in order to do that, after I have found the empirical formula, I need an extra piece of information, and that is I need to know the molar mass of the compound, which has been found to be 204 grams. So to go from the empirical to the molecular, I know the molecular has to be a whole number multiple of the empirical. Again, think of the empirical as sort of the reduced form of the molecular. So I'm going to need to find what is that multiple that exists between molecular and empirical. So if the formulas are ratios or multiples of each other, then the masses would have to be also. So I'm going to take the actual molar mass that they gave me and divide by the molar mass of the empirical formula. So I took CN4, went to my periodic table, and was able to determine that the molar mass was 68.05. I'm going to go ahead and divide that, and I find that that goes into 204 3 times. So if the masses are in a ratio of 3:1, then the components would have to be in a ratio of 3:1. They're the ones who provided the mass. So I'm going to multiply my empirical formula by 3, and I end up with the true formula for this compound. It is C3N12. You always have to be given the molar mass if you're going to find the molecular formula.